Have you ever looked at a massive skyscraper or a huge dam and just wondered how on earth do they build something like that without going completely broke? Well, today we're diving into that exact question, going all the way from the blueprint to the bottom line.
Let's put it this way. How do you bet $1 billion and actually come out on top?
I mean, that is literally the scale we're talking about here. Projects like this hydropower dam involve investments that are just mind-bogglingly huge. And the risks are even bigger.
So how do they pull it off? How do the pros navigate these absolutely colossal risks? Well, the answer is in this super important and kind of fascinating field called engineering economics. All right, so that brings us to our first big idea, the billion-dollar question. Before a single shovel ever hits the ground, every single project has to answer this one fundamental question. When do we stop hemorrhaging money and actually start making it? It's like the #1 hurdle you've got to clear.
And the very first tool we're going to pull out of our engineering economics toolkit to answer that question, it's all about finding your break-even point. Now, to get to that break-even point, you've got to know about two different kinds of costs. First, you have your fixed costs. Think of things like rent, salaries, the stuff you have to pay every month no matter what. And then you have your variable costs. These are the costs that go up and down with how much you're producing, like your raw materials. And when you put them together, you get this really simple but super powerful little formula. Your total costs are just your fixed costs plus your variable costs. Pretty much everything builds from here. All that simple math leads us to our big goal, the break-even point. This is that magic number, that exact moment where the money you've spent is perfectly equal to the money you've brought in. It's the absolute bare minimum you have to achieve just to avoid losing money. Let's make this a little more real. Take a look at this example from a cable manufacturing company. Their fixed costs are $800,000. Their variable costs to make 5,000 units are $400,000. So all in, their total costs are $1.2 million. But look at their sales income, $1.5 million. At this point, they're in the clear, they're making money. The break-even analysis is what tells them the exact moment they cross that line from loss into profit.
So really, it all boils down to this. Stay below that break-even number, you're losing money, you're in the red. Get above it, and you're finally making a profit, you're in the black. It's the financial dividing line for the entire project.
Okay, so that seems pretty straightforward, right? You calculate your break-even point, you hit your target, easy. But that's assuming everything goes according to plan. And this is where things get complicated. Because what happens when the real world gets messy? Where the price of a key material suddenly doubles, or a freak storm floods your construction site. Your neat little plan can fall apart fast. For a perfect example of this, just look at building hydropower dams in Nepal. In a project like that, uncertainty isn't just a possibility, it's an absolute guarantee. The geology is a question mark, local politics can be unstable, the weather is extreme, a simple break-even model all on its own just isn't going to cut it here. And that's exactly why engineers need a whole other set of tools. Which brings us to our next section, mapping your risks. And believe me, we are not talking about some abstract what-if scenarios. The research shows these projects in Nepal face very real, project-killing problems. Things like land acquisition disputes, public disorder, finding out the ground you're building on isn't what you thought it was, even sudden changes in government rules. Any one of these can blow your budget and timeline to pieces. So, how do you even begin to deal with all that? Well, you start by trying to organize the chaos. And to do that, project leaders use a really clever tool called a probability impact matrix. Okay, so this is the tool. It might look a little technical, but the idea behind it is actually super simple. It helps teams see all their risks on one page by plotting two things against each other. On one axis, you have the probability. How likely is this thing to happen? And on the other, you have the impact. If it does happen, how bad is it going to be? Right away, the stuff in the green is low priority. But anything that lands up in that red zone, well, that's what you need to focus on. That's a critical threat. And this is what you get. The matrix takes that big, scary cloud of what-ifs and turns it into a clear, prioritized action list. In this case, land acquisition problems came out as the #1 biggest threat. Public disorder is #2. So now, you don't just have a list of things to worry about, you have a battle plan. You know to put your best legal team on the land issues from day one, and to invest heavily in community relations to manage public disorder before it even starts.
So let's bring it all home. It's time for making the final call.
There's this quote from the source material by Smith and his colleagues that just nails it. They say, Risks can frequently be avoided if their root causes are identified and managed before the adverse consequence occurs. That word, before, that's everything. It's not about reacting to disasters, it's about being proactive and preventing them from ever happening.
So what's the key takeaway here? It's that these two tools, your break-even analysis and your risk analysis, they work together. Your risk mapping tells you which costs are most likely to spiral out of control, which directly threatens your break-even point. At the end of the day, engineering economics isn't about having a crystal ball to predict the future. It's about using these tools to turn what looks like a wild billion-dollar gamble into a smart, calculated decision.
And that leaves us with a final thought. It doesn't have to be a massive dam. It could be a startup you're launching or a big career move. What are the hidden risks and what are the break-even points in your biggest project?